Let us now see this question. Encrypt a given plain text must with key 15 uses Caesar cipher. As discussed in previous videos, the step 1 is to use the mapping table. Since the encryption algorithm that we are using is C is equal to P plus K mod 26 and the key that is given to us is 15 while the P is the letter must. So the first step is that we have to map each of these letters to numbers. So in order to map these letters into numbers, we have to make use of the mapping table in step 1. So we use a mapping table now and assign numbers to each of these letters. For example, for M, we assign the number 12. For number U, we assign the number 20. For number S, we assign the number 18. For number T, we assign the number 19. So we have to assign numbers to each of the letters so that we can use this formula and we can encrypt it. Going ahead with step 2. In step 2, we create a 3-column table. In the first column, you write down your plain text, that is MUST. Write its corresponding number, which you have to then process it using encryption formula. So M, as we just saw, corresponds to 12, U corresponds to 20, S corresponds to 18 and T corresponds to 19. I got these numbers using this mapping table. So these numbers are now processed with the encryption formula, which is P plus K mod 26, where the key K in our case is 15. So to each plain text number, we have to add 15 and do the addition in mod domain. So let us see the addition now. So 12 plus 15. What is the answer we get? We get 27 mod 26. You have to check, is 27 greater than 26? Yes, it is greater. Therefore, you have to do modulo arithmetic. So how do you do modulo arithmetic? You divide the number 27 with 26. So 26 into 1 is 26 and the remainder is 1. So the remainder that we get is 1 and hence my ciphertext number is 1. The next number is 20 plus 15. What is the resultant? 35 mod 26. Since 35 is greater than mod 26, you have to perform modular arithmetic. How do you perform modular arithmetic? You divide the number 35 with 26. So 26 into 1 is 26 and the remainder is 9. So the remainder is your final answer. Next is 18. So 18 plus 15. How much is the total? 33 mod 26. Now 33 is a number which is greater than 26. So you have to do modular arithmetic. How do you do modular arithmetic? You divide the number 33 with 26. So 26 into 1 is 26 and the remainder here is 7. So 7 is the answer. The remainder is always the answer of mod's operation. The next number to be encrypted is 19. If I add 19 plus 15, I get the answer as 34 mod 26. Now 34 is a number which is larger than 26. So I have to do modular arithmetic. So how do I do? I divide 34 with 26. 26 into 1 is 26 and my remainder in this case is 8. So the remainder is the final answer of modular arithmetic. So 27 mod 26 is 1. 35 mod 26 is 9. 33 mod 26. The remainder is 7. 34 mod 26. The remainder that we got after division of 34 by 26 is 8. So these are our ciphertext letters. The next step is to find the letters corresponding to each of these numbers, for which we need the mapping table. So we again use this mapping table. The letter corresponding to 1 is B. The letter corresponding to 9 is J. The letter corresponding to 7 is H. The letter corresponding to 8 is. So for the given plain text must, we have got the ciphertext as B, J, H, I. So in the next slide, we'll see how to decrypt this and recover a plain text back. Let us now see the following question, which is given as decrypt the given ciphertext B, J, H, I using the key 15. So as all of you know very well by now, that the first step is you're supposed to use the mapping table. The second step is that you should use a 3-column table. First column you should fill up with the ciphertext letters. So let us do that. So the letters given are B, J, H and I. Now we have to assign numbers corresponding to these letters, which we do using the mapping table on the left. So what is the number corresponding to B? It is 1. So we write 1. What is the number corresponding to J? It is 9. So we write 9. What is the number corresponding to H? It is 7. So we write 7 here. What is the number corresponding to I? It is 8. The algorithm that is used to do the computation of the plain text is C minus K mod 26. So once you write down the ciphertext characters and their corresponding numbers, we now move on to the computation step. For computation, we require the key. The key that is given to us is 15. The computation that we have to do is we have to take the ciphertext number, subtract 15 using mod 26. Now we have to check out how the subtraction is done in modular arithmetic. So let us do that. So the first number that is given to us is 1. So I have to deduct 15 from it. So what is the answer I get? Minus 14 mod 26. Now since I got minus 14, I have to do modular arithmetic. The moment you get a negative number, you have to do modular arithmetic. So since I got a negative number, I will perform modular arithmetic. That is, I should bring this number minus 14 within the range of 0 to 25. How do I do that? I do that by adding 26 to this. When I do minus 14 plus 26, the answer is 12. Now 12 mod 26, if you check, 12 is a number which is positive and it is less than 26. Therefore 12 is my final answer. Now let us take the next number 9. So if I do 9 minus 15, my answer is minus 6, and we are doing this in modular domain. So mod 26. Now you check this number here. It is minus 6. Since it is minus 6, you have to do the mod operation on it. That is, bring minus 6 within the range of 0 to 25. How do you do that? You take minus 6, add 26 to it. The answer that you get is 20 mod 26. So you see that you got a number 20 and which is less than 26. That means 20 is a number between the range 0 to 25, and hence 20 is your answer. Now next number which is given is 7. So 7 minus 15 is minus 8 mod 26. Again, I got a negative number. Because I got negative number, I'm supposed to do modular arithmetic. That is, I take minus 8 and add 26 to it and check out my answer. I got 18 mod 26. Now I check whether this number 18 is positive and is it lesser than 26? Yes. So my final answer is 18. Now I do 8 minus 15. I got as minus 7 mod 26. Since I got a negative number, I have to do modular arithmetic. So I repeat it again. I do modular arithmetic so that this number minus 7 is brought within the range of 0 to 25. So I have to take minus 7, add 26 to it. I get the answer as 19. Then you see that this 19 is a number which is positive and it is less than 26. That is, it is within the range of 0 to 25, and hence 19 is my final answer. So the plain text numbers that you got is 12, 20, 18 and 19. For the ciphertext numbers 1, 9, 7 and 8. Now we have to convert these numbers into letters. To do that, we require the mapping table. So we take the mapping table now and assign the letters to this number. So you can see that from the mapping table, the number 12 is for letter M, number 20 is for letter U, number 18 is for letter S, number 19 is for letter T. So you saw that the ciphertext BJHI is now decoded as the plain text, that is MUST must. So this is your final answer. The ciphertext BCJI has now been decoded as plain text must. I hope you understood the numerical. If there is any doubt, kindly put it in the comment section. See you all. Take care. Stay healthy. Stay happy. Stay blessed.